On this page, we want to find f of g and g of f in the domain of each, given these two functions. I'm splitting the page in half so we can do both, and I'm starting with g of f first because it is easier. So g of f is the same as g of f of x. So remember, that is g of x with f of x plugged in instead of x. So g of f of x is the square root of the square root of x minus 2 squared minus 1. G of f of x is the square root of x minus 2 minus 1. So g of f of x is the square root of x minus 3. So that's the first part they're asking for. Now we need to find the domain. So step 1. Our inside function is f of x equals square root of x minus 2. For its domain, we know what's inside of this square root must be non-negative in order to get a real number. So that means x minus 2 must be greater than or equal to 0. X is greater than or equal to 2. So that's the same as 2 to infinity. Okay, so that is the domain of f of x. Now, for step 2, we take the composite function, g of f of x, which we already found to be the square root of x minus 3. Now, for this composite function, what's inside of the square root must be non-negative in order to get a real number. So this tells us that x minus 3 must be greater than or equal to 0, or x must be greater than or equal to 3. So the domain of f of g of f of x is from 3 to infinity. So now remember, the overall domain is the intersection of these two domains. So if I have, let's look at them on a number line. For my first domain, I have from 2 to infinity, right? And for my second domain, I have from 3 to infinity. Their intersection is where those two overlap on the number line. So that means that our overall domain is from 3 to infinity.